Morning, everyone. My name is Christian Baiso, a student of Manuel S. Barca University, and now I will present to all of you a prototype of solar power irrigation system. This is my solar power irrigation system. Solar panel, or more accurately, photovoltaic solar panels generate electricity from the sun. The more powerful the sun's energy, the more power you get. Although solar panels continue to generate small amounts of electricity in the shade, most solar panels are made up of individual solar cells connected together. A typically solar cell will only produce around half a volt, so by connecting them together in series inside the panel, or more useful voltage is achieved. The output of this panel is 7 volts DC, and the wattage of solar panel is 18 watts. The second component of solar irrigation system is solar charge controller. Solar charge controller, if you are using batteries, your solar electric system is going to require a controller in order to manage the flow of electricity, the current into the and out of the battery. If your system overcharges the batteries, this will damage and eventually destroy them likewise. If your system completely discharges the batteries, this will quite rapidly destroy them. A solar controller prevents this from happening. There are a few instances where a small solar electric system does not require a controller. An example of this is a small battery top-up solar panel that is used to keep a car battery in a peak condition when the car is not being used. These solar panels are too small to damage the battery. When the battery is fully charged, in the majority of instances, however, a solar electric system will require a controller in order to manage the charge and discharge of batteries and keep them in a good condition. The third component of solar irrigation system is the battery. Batteries, solar panels, rarely power electrical equipment directly. This is because the amount of power the solar array collects varies depending on the strength of the sunlight. This makes the power source too variable for most electrical equipment to cope with. If you are storing your solar energy, such as in a standalone or grid fallback system, this energy is stored in batteries, as well as allowing flexibility as to when you use your energy. The batteries provide a constant power source for your electrical equipment. There are different battery technologies available for solar energy storage. Traditionally, deep cycle lead acid batteries have been used. These batteries look similar to car batteries but have a different internal design. This design allows them to be heavily discharged and charged several hundred times over. Most lead acid batteries are 6 volt or 12 volts batteries. Unlike solar panels, this can be connected together to form a larger battery bank. Like solar panels, multiple batteries used in series increase the capacity and the voltage of a battery bank. Multiple batteries connected in parallel increase the capacity whilst keeping the voltage the same. The output of these batteries is 6 volts and 4.5 ampere hour. The fourth component of solar irrigation system is the inverter, and the output of this inverter is 12 volt to 6 volt DC, and you have 3 ampere and 8 watts. Inverter, the electricity generated by a solar electric system is direct current. Electricity from the grid is high voltage alternating current. Easy if you are planning to run equipment that runs from grid voltage electricity from your solar electric system. You will need an inverter to convert the current from DC to EC and convert the voltage to the same voltage as you get from the grid. Traditionally, is usually central inverter in a solar system, either connecting directly to a solar array in a grid-tied system, or the battery pack in an off-grid system. A more recent invention has been the microinverter. Microinverters are connected into individual solar panels so that each individual panel provides a high voltage alternating current. Circuit breaker. A circuit breaker is an electrical safety device that serves to protect an electrical circuit from damage caused by excessive current, overcurrent, or interrupt current flow to prevent equipment damage and fire, or consists of two main contacts, a fixed contact and a moving contact, automatically trip and shut off current flow when a fault is detected. These are the load of irrigation system, which is DC LED light and the DC motor pump. And I will start to operate a solar power irrigation system, and I open the circuit breaker. The output of battery is 6.23 volt DC, and the input in circuit breaker protection is 5 volt DC, and the output of circuit breaker is 4.96 voltage. And I will show you the current of load irrigation system have the result of 0.008 ampere in the load side of irrigation system. And the motor is 4.89 ampere. And this is the functionality of solar power irrigation system. And I will put this water in the, and you can see this. And that's all my report of prototype of solar power irrigation system.